Morocco's skylines are changing, and they're changing fast. From Casablanca all the way to Marrakesh, new buildings are popping up everywhere. But you know, all that amazing growth comes with a hidden cost, a massive demand for energy. So, how does Morocco keep building its future without overwhelming its energy supply? Well, the answer is in a really important set of rules called the Moroccan Thermal Building Regulation, or, as it's known, the RTCM. Let's get into it.
All right, here's our game plan. First, we're going to dig into the energy challenge Morocco's really up against. Then, we'll see how the government responded with new regulations. After that, we'll decode the RTCM itself, get into the nitty-gritty. We'll also check out the tools that make compliance possible, and finally, we'll look at what this all means for the future of building in Morocco.
So, first things first, why was this whole regulation needed in the first place? I mean, to really get why the solution is so important, you first have to understand the sheer scale of the energy problem Morocco is facing.
Okay, so if you look at where all of Morocco's energy is going, yeah, transport is the big one, no doubt. But the real story, for what we're talking about, is in the buildings. See, if you combine the energy used in our homes, the residential sector, and in commercial buildings, you get a massive 25% of the entire country's energy use. That is a huge slice of the pie and a perfect target for making things more efficient.
Just let that sink in for a second. 1 out of every 4 kilowatts of power used in the entire country is being consumed inside a building. So you can see, if you want to make a real, meaningful dent in national energy use, this is exactly where you have to start.
And this issue goes way deeper than just saving energy. For Morocco, a country that imports almost all of its energy, this is a huge deal. It's a matter of national strategy. So cutting down how much energy our buildings use isn't just good for the planet, it's absolutely critical for the country's economic stability and its energy independence.
Okay, so the problem was crystal clear. How did Morocco respond? Let's take a look at the official legal framework that was created to tackle this challenge head-on.
So the cornerstone, the absolute foundation of this whole effort, is a law called Law 47-09. This is the high-level legislation that really sets the stage for everything that follows. It's what brought in the concepts of mandatory energy audits, minimum performance standards, and it paved the way for all the specific codes we see today.
And here is the key takeaway. If that Law 47-9 is the overall strategy, think of the RTCM as the detailed playbook. It is the specific, mandatory rulebook that every architect, engineer, and developer has to follow for every single new residential and commercial building, no exceptions.
And believe me, these rules aren't just for show. They are driving some incredibly ambitious national goals. Morocco has actually upped its energy-saving target to 20% by 2030 and is aiming for a huge 42% cut in greenhouse gas emissions. And what's so powerful here is the idea that hitting these massive national targets all starts with making just one building at a time more efficient.
Okay, let's get into the technical stuff. If you're an architect or an engineer working on a project in Morocco, how do you actually prove you're following the rules? Well, the RCTM actually gives you 2 different paths to choose from.
So the RTCM gives you a choice. You can go for flexibility or you can go for simplicity. The first option is the performance approach. This one is all about giving you design freedom. It sets a total energy budget for your building, but it lets you decide how you want to meet it. It's fantastic for really innovative designs, but you're going to need some pretty complex simulation software. The other option is the prescriptive approach. This is way more straightforward. It's basically a checklist. Use this much insulation, this type of window, and so on. It's simpler for sure, but there's a big catch. You can only use this method if your building's design has less than 45% glass on its facade.
And what's really smart about this code is that it understands geography. It knows that a building on the coast in Agadir is facing a completely different climate than one out in the desert near Arashia. So, the country is split into 6 climate zones, and the energy targets actually change depending on where you are. For instance, a building in the mildest zone has a really strict target of 40 kilowatt-hours per square meter per year, while one in the most extreme zone is allowed up to 65, to account for those much tougher conditions.
So what exactly does the code look at? Well, it focuses on what we call the building envelope, basically the entire shell that separates the inside from the outside. We're talking about the insulation in your walls, your roof and your floors, the performance of your windows, which is measured by something called U-value and solar factor, and even smart design choices, like which way the building is oriented and how you use things like overhangs to shade it from the sun.
Okay, trying to manage all of those variables and calculations sounds pretty complex, right?
Well, the government saw that coming, so let's look at the official tool they developed to make this whole compliance thing a lot more straightforward. This quote from Mohammed Ahachad at ADERE, that's the National Renewable Energy Agency, it says it all. He's basically saying that the BINA2V software is what allows companies, architects, and engineers to design and build their projects while staying within the rules. It's the official key to getting your project approved.
So, while BINA8 is the official government tool that you use for the final verification, the industry also uses a whole range of other powerful simulation software during the design phase. You know, tools like Design Builder or Autodesk Ecotect. They let architects and engineers model and perfect a building's performance long before they're ready to submit for a permit.
So the process, the actual workflow, becomes pretty clear. Step 1. The architect or engineer designs the building. Step 2. They use software, like Binyate, to calculate its energy performance. Step 3. They verify that the design actually meets the RTCM targets. And finally, Step 4. They include that official compliance form right there with the main building permit application. It's now a core part of the whole approval process.
All right, let's zoom out one last time and look at the bigger picture. Why go through all of this trouble? What are the real-world benefits here, and where is this all headed in the future?
Now, it's really important to see that this isn't just about red tape or bureaucracy. Complying with the RTCM delivers real, measurable value. For developers, it means getting your permits approved faster, and it means you invest smarter because you're not over or undersizing expensive systems. And for the people who actually use the building, it means they're more comfortable, they have lower energy bills, and ultimately, that increases the property's market value. It's a win-win-win. And you've got to know the RTCM isn't some static rule book that's set in stone. It's designed to evolve. It became mandatory back in 2015, and right now in 2024, a major evaluation is happening to see how it's working. This means we can probably expect some updates and maybe even stricter requirements in the next couple of years as Morocco keeps pushing toward its ambitious 2030 goals. This is very much a living document.
So, there you have it. The RTCM provides this powerful framework for building a more sustainable Morocco. But the final question, really, is whether a code on a piece of paper can actually translate into a real-world transformation. The regulation sets the minimum standard, for sure, but its ultimate success? Well, that depends on the industry's commitment to go beyond just checking a box and to truly start designing the resilient, ultra-efficient buildings that the future is going to demand.